Hello Year 11 and welcome to our 6th video here on probability. We're looking at probability tree diagrams today, and we want to be careful to distinguish these from the tree diagrams that we did right at the beginning of this topic. Now they certainly look very similar, with a distinction here that on a probability tree diagram the branches represent an event rather than an outcome, and that helps us to simplify. Right, to simplify these tree diagrams so we don't get, well, typically 2 to the power of however many stages we have. Right? Keeps it a bit tighter. We're going to jump straight into an example here to show you how these work. Now, this is a fairly complex situation here that's described. A bag contains 5 blue marbles and 7 red marbles, 12 marbles altogether. A marble is drawn at random from the bag, that's fine. Now, if it's blue, we keep it out. If it's red, it goes back in. Then we repeat that 2 more times. So at the end, I might have taken 3 blue marbles out, in which case I only have 9 marbles left in the bag. Alternatively, I might have taken out 3 red marbles, in which case they've all been put back in and there's still 12 marbles in the bag. Right, it is a reasonably complex situation. So we start off. First ball, we're asked to find the probability of these two things. So, first ball out of the bag. Might be blue, might be red. And we label those branches with the probability of that event. So the probability of drawing a blue marble from that bag is 5 in 12. There are 12 marbles in the bag. 5 of them are blue and 7 of them are red. Okay, so you can see here the difference is we have a probability labelled on the branches. Now the second ball comes out. Let's say the first ball was blue. Right, then I could draw a blue or a red, but if the first ball were blue, then now there are only 11 marbles left in that bag because I've taken one out and left it out. Of those 11 marbles left in the bag, 4 of them are blue. So the probability of drawing a blue ball after a blue marble is 4 in 11. Right, the probability that that ball taken out then is red is 7 out of 11. And you'll notice here that those two fractions add up to 1. What about the probability if the first marble was red? Then there are still 12 marbles left in that bag. 5 of them are blue, so there's a 5 in 12 chance of drawing a blue marble, and a 7 in 12 of a red. So remember, along this path here, I put the marble back in the bag and there will still be 12 marbles in that bag. This blue marble will stay out. In this case here, 1 blue marble has been taken out and there are still 11 marbles in the bag. But in this case here, right, blue then blue, there are only 10 marbles left in the bag in that instance. So here we go. There's the last of the stages with those probabilities. 3 in 10, 7 in 10, 4 in 11, and 5 in 12 here. Okay. So that is each of those 3 stages with the probability of each event listed on the branches. Now I should list my outcomes here at the end. So the first outcome here, blue, 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 right? And then blue, blue, red, and blue, red, blue, and so on. So there are my 8 outcomes. And to calculate the probability of each of those, I should probably call them events, right? Each of these events, because there are some conditions applied. So blue, blue, blue is 5 in 12, 4 in 11, 3 in 10. Right, we multiply those together and simplify, get 1 in 22. Right, to draw a blue, then a red, it'll be 5 in 12 times 4 in 11 times 7 on 10. Okay, and that simplifies to 7 on 66. Get out of the road here. And we continue that for each of these other outcomes. 5 and 12, 7, 11, 4, 11, 35 and 363, and so on. Now, if I add these 8 numbers together, right, each of those probabilities, if I add them all together, they'll add up to 1, because between them, all of these are mutually exclusive, all right, and the union of these 8 spaces will be the universal set, right, and the probability of all of those together will be equal to 1. Right, so now that we've done that, that's most of the hard work. Let's have a look. 1 blue marble. Now, if I draw 1 blue marble only, it might be the first time I draw a marble out, it might be the second time, or it might be the third time. So there should be 3 outcomes. And here they are. The first one, blue, red, red. And the probability of that occurring is 245 on 1452. The second way I could make that occur is red, blue, red. So my second marble is blue, red, and that's 245 on 1584. And finally, the first 2 marbles might be red, 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 and then blue, 245 on 1728. Now, a funny thing happened here. When I tried to add those 3 fractions together on my calculator wouldn't do it. It certainly wouldn't do it as a fraction. It would only give me the decimal. It wouldn't convert it back to me. So I had to do it sort of the long way around. It sure was fun. So 97,265 over 209,088 is the probability of that occurring. It's about 40% chance. Here you are. So that's a little curiosity that doesn't happen very often, that we get an expression that's too complicated for our calculator. Anyway, that's the first answer generated there. The second one, 3 blue marbles. Okay, well that's a bit more simple really, because, right, that's just like this. Blue, blue, blue. That's only one of the outcomes. We've already calculated that. It's 1 in 22. Now, for these sorts of questions, you don't typically draw the whole tree and calculate all of those probabilities. So for example, red, red, red wasn't part of any of my answers, so I really didn't need to calculate those ones out. You can see there were some of them here that I didn't use at all. Look, I just did that for the sake of this example, calculated all of the probabilities rather than just the ones that are required for the questions that are being posed. But anyway, you can see there that's a probability tree where the branches represent events, and I have the probability of those events listed on there. Okay, and I find, excuse me for a moment, and I find the probability of that multi-stage event by multiplying each of those probabilities together. Right, and if I have a number of different events that all go together, well, I can add those at the end. Rightio, so that is probability trees. Quick sum up. Okay, probability tree diagrams have branches representing events rather than equally likely outcomes, and the probability of a multi-stage event can be found by multiplying the probability of each stage's event. Next thing is conditional probability. If you've got any questions about probability trees, please make sure that you ask me during class. I'll see you there.